Hello and welcome to IQ Toolkit, your database intelligence channel. I'm Gio, I'll be your host. And today we are going to talk about PostgreSQL and its toast mechanism. What is toast? Toast is the oversized attribute storage technique. Postgres, by default, we always try to put a single row in an 8 kilobyte page. But what happens when the data is bigger than 8 kilobytes? That's when toast kicks in. I'm using this table, demo sales, in my IQ Toolkit demo database. So let's take a look at that table. We have two integer columns, one numeric, one timestamp, and another text. Nothing out of the ordinary, right? Great. But let's dig deeper and let's dig into what kind of storage class we have. Let's execute. So we have plain, we have main, and we have external. We integer and timestamp, plain, numeric is main, and text is external. So let's start with plain. Plain is for fixed length and a small variable length. Forces to be stored in line, forbids both compression and out-of-line storage. These columns will never be moved to a toast table or will never be compressed. Now, main. That is numeric. This strategy allows compression, but avoids out-of-line storage as long as possible. The data only is moved to a separate toast table, but is only a last resort mechanism. So it will always try to do compression first, and that will be the first mechanism. And it makes sense for numeric, because numeric usually it shouldn't be that big that it doesn't fit in 8 kilobytes. Although I have to say it can be so big that it will need a toast table. It can be. But on normal circumstances, it should. So it makes sense that it's made. Now, let's talk about external. Okay? External, to put it in external here, I had to run this query, an alter statement, to set the column to external. What did that do? This forces that column to allow out-of-line storage in a separate toast, but disables compression. And I did it for the demo purposes. This can increase storage space, but can improve performance for specific operations. And I did this just for demo, but there are specific reasons for what you might need to do this. For example, if you have to do substring, or you have a very large text or byte A, and if you don't do that, Postgres by default is going to compress and put it in split it into toast tables. To read it, Postgres has to decompress and read it. If you don't compress it, if you just put it as an external, you skip the compression and decompression. You save a lot of CPU there. Yes, it has a cost. It has a cost of sometimes a lot of disk. But that depends on what are your requirements on data, on query performance. Sometimes that is the price we have to pay. It all depends on your needs, right? Okay. So, but then if I didn't run this alter statement, this column would have been the default text storage class, which would have been extended. Extended allows both compression and out-of-line storage. It will try compression first, and if it's still not enough, then it will still chop the data and move it to those tables, but it will move it into compressed pages. So yeah, and in certain circumstances that's perfectly fine. So it's on a there is no permanent rule. It's Postgres performance tuning is more of an art than a science per se. So let's keep going with the demo. Let's keep going and let's see first, what do we have here in the demo. So in the amount, we have 366 and 35 cents. So not a big deal. And if we do explain analyze, look at that. Share hit is 4. So it only has to hit 4 pages. 32 kilobytes of memory. Okay. I'm going to go and do select ID MD5 function here, notes, and I'm doing this to force Postgres to always read the whole notes from demo sales where ID equals 1. So there it is. Great. Now, if I do the explain analyze, look at that. Even though it's text and it's extended and it's uncompressed, everything fits in 4 pages. So just as numeric. Great. So because you see buffer share hit is 4. So it only had to touch 4 pages. Great. Now, let's take a deeper look to the size of the table. Okay. So demo sales has 15,385 pages. The size is 120 megabytes. Okay, small. Now let's talk about the column size of notes. And this is basically the size of the record of notes for ID equals 1. Okay? 65 bytes. Great. And now let's talk about the length of the notes. Okay. 64. Great. Now, let's do this update, and we're going to update the demo cells. We're going to set nodes, and we're going to use this repeat function. We're going to repeat IQ Toolkit Architecture Series toast 2 million times. Yeah, why not? We are done. Now, let's revise the size of the table. Look at that. The table didn't grow. What happened to the data? I mean, I added a lot of data. Demo sales, 15,385 pages, 120 megabytes. That's exactly what we had earlier. But, okay, let's see if the size of the nodes is the same. It shouldn't be. And it isn't. From 64 bytes, it grew to 74 megabytes. And how about the length? Oh, wow. From 64, I think, or something like that, to 78 million. Wow. It's something. So where is the data? Simple. In the toast table. 76 megabytes in this. That's it. Now, we added data. Let's run this explain analyze on, let's see if there are changes. Let's start with ID and amount. It shouldn't have because we didn't touch amount, but let's see. Share hit is 4. We keep touching 4 8 kilobyte pages. That's perfect. But now nodes is bigger. What happened now? Look at that. It had to touch 9,882 pages. And they all had to go into the shared buffer, kicking out data from other queries. This is definite proof of why select start is dangerous in production. If you had run select start on this table, your application would have dragged 74 megabytes of data across the network for one user. And if you didn't need the nodes column, you would have pushed 74 megabytes of data out of the shared buffer that were completely needlessly. Like, you didn't need that. And you would have pushed that 74 megabytes from other data that you might need it for other queries. So this is the lesson is know your data types. 1. 2, if you have large text, keep it in a separate table or use the external strategy if you don't need compression. And 3, never select columns you don't need. I hope this demo helps you tune your own databases. If you enjoyed this deep dive, hit that subscribe button. I'll see you in the next one.